Hi, I would like to introduce you Numeric Sublibrary from CAS Standard library. Numeric Sublibrary consists of 4 parts: blocks for addition, blocks for subtraction, blocks for multiplication, and blocks for division. Let's start with functionality for addition. The main purpose of those blocks is to have 1-pin blocks. As you can see, we can extend this block to have it longer, or we can remain it like it is. We can directly write the value into the block or to this version. There is only one difference between two blocks, that this block is for real values and this block is for unsigned integer values on the input. We can also write the value into the block according to the variable which is used inside. So let's define variable for real or unsigned integer. So we can write the value for var r like that, which is number 8, and for var unsigned integer like that. For this unsigned integer block. And then we can connect value on the input. We can also use this block like a double input block for both versions. In that case, if we connect this variable unsigned integer and variable real like that, so those 4 blocks are equal. Let's try it. 5 plus 15 is 20. 5 of unsigned integer plus 15 is 20. 12.0 plus 8 is 20. 12 for unsigned integer plus 8 is 20. Those two blocks are equivalent, so let's try it. 12.0 for real values is 20. 12 plus 8 is also 20. So we can easily space optimize our graphical programming with standard numerics for addition functionality. Next group of functionality is subtraction. So we have 3 blocks for subtraction. So first block is subtraction for real values, second is for unsigned integer, and the third is inversion subtraction of the real values. We can similarly extend those blocks into 2 pins blocks. And extend it to be wider. We can write the value directly into the block, like 15, 15, and 15. Or we can write the name of the variable inside. So var real. Var real 15, which has the value 8. So now we have connected inputs. Let's change the values to 8 to have the same functionality in the group. The same, and this is 8. 8 and 8. Now this group is equivalent, this group is equivalent. Maybe var unsigned integer would be better. And now this group is equivalent, this group is equivalent, and this group is equivalent. One small thing, variable unsigned integer is equal to 8. So I have to have equivalent group, I have to fix it to 8. Pardon. Now this group is also equivalent. Now the first input is everywhere 0, so on real data type you can see that the 0 minus 8 is minus 0, minus 8, minus 8. This inversion subtraction has opposite functionality, so it's 8 minus 0. So 8 minus 0 is plus 8. That's the difference between this normal subtraction and inverted subtraction. That's the difference between those two groups. And 0 minus 8 on unsigned integer, it's behind the data type, so it's this number. If it's number 10, so it will be in unsigned integer range for all of those. For a real data type, we should have the same value for number 10 minus 8, which is 2.0, and for unsigned integer is number 2. For 8 minus 10 it will be minus 2, because the order of those values is inverted. So first is 8 and then number 10, so 8 minus 10 is minus 2. That about subtraction. Next functionality is multiply, which has again one pin input with possibility to extend it to standard double input, and then we have also division functionality, which has also one pin input division and double input division. Those values are only for real data types, so if it's 8, so this 8 is basically this second input, so we can create value field for 8 like that. And we can write the value directly. So val r and val r, which is defined to 8. Pardon, val r. So you can see that we have to write it precisely, because it's a var r value, so not val but var r, and then it's possible to write it correctly. And to have equivalent we have like that, number 8. Let's try it. 8 multiplied 8, it's 64. Yes. And 64 divided by 8 is 8. And it works. Perfect. Something a little bit more harder. So 64 multiply 8 is 512, and 512 divided 8 is 64. Next block in the library is average. Average is just simple average of two numbers. It's not possible to extend it. Or you can extend it by average of average, but then it has a little bit different functionality. So if we create two average blocks, any value, for example variable real, we have already defined to 8, and we will let open the second value. So the result is 4 in case that average of 0 plus 8 is 8 divided 2 is 4. If we have an average of two values, which one is 8 and second is 8, so the average is 8, and so on. Last block from Numeric Sublibrary is EVAL block. This block is possible to extend like that, and the main functionality is that you write the formula for polynomial function in different format, and you will get the result of on the output of the type real. So I will change a little bit the formula for the first one, which is x plus x, for example, because we have it on the input. Let's this formula like that, and we will define freely the third formula in online format. For example, like this. So we have formula x plus x, which is 6. Then a multiply x plus b multiply x plus c, which is basically a 2 plus b 4 plus c. So 2 plus 4 plus 5 is 11. And then I created a formula like that: x plus a multiply b plus c in parentheses divided by 2, the result multiply by itself 3 times, so root to third minus 4, which is 121, and we can, for example, write there sqrt parentheses, so the result will be square root, which is 11 from 121. If I change it to 2, so we can see that it's dynamically changed. And 11 plus 4 is 15. So we have dynamical chain, dynamical string for formula, and we can define any polynomial or any polynomial function for converters of analog inputs or whatever we would like to do dynamically. For example, even from HMI, if we connect those values into the set points. And that's it from Numeric Sublibrary of CAS Standard library. Thank you.